I'm going to check here is what happens when we multiply the function times a number. Well, we know the basic x squared function, 4, 1, 0, 1, 4. That's one we should get to know. It is just really helpful if we can do that without thinking about what the squares are. So this was my f of x. Now my g of x, I'm going to take 2 times it. So I square it and then double it. So square it is 4, double it 8. Square it is 1, double 2. Doubling 0 is still 0, 2, and 8. So I'm here, 0, 0, and then 1, 2, 2, 8. 1, 2, and 2, 8. What has happened is it got skinnier. I took it times 2 and it got skinnier. Let's see what happens when we take the same function and take it times 1/2. So we'll still have the 1, the 4, 1, 0, 1, 4. So we'll have our basic function here, and we should, as I said, be able to know what that one is pretty easy. That's my f of x. Now we're going to take half of that. So half of that is 2, half of that is a half, half is 0, half of 1 is a half, and half of 4 is 2. So 0, 0 we still have, but we have 1, 1/2. We have 2, 2. We have the 1/2, and we have the 2. Notice I'm just going up half as much on those. And for 3 it would be 9, so it would be at 4.5. So what happened here is it got fatter. Now, what they do sometimes, these really have the same effect. If you take the number, if a is positive, if you take it times it gets taller or skinnier. If a is between 0 and 1, it's still positive, but it's between 0 and 1, it's shorter or fatter. Now, if you put the a and you multiply it times the x before you actually do the function, it still gets skinnier or taller, and it still gets fatter or shorter. So for this, when you're multiplying the whole function times a or just the x times a before you do the function, it has the same effect. Now we want to talk about symmetry. If it's symmetric about the y-axis, if you take f of negative x and it turns out equaling f of x for any value of x in the domain, then it's called an even function and it's symmetric about the y-axis. If you take f of negative x and it turns out that everything is just negative of the whole function, so all the signs end up being different then for every value in the domain, then it's called an odd function and it's symmetric about the origin. Here we want to check the symmetry algebraically, and what we do is we find f of negative x. So we make negative x to the 4th minus 2 times negative x squared. Well, negative x to the 4th still turns out to be x to the 4th. And negative x, the quantity squared, turns out to be x squared. So in this case, my f of negative x turns back to equal the original, So it equals f of x. That means this is an even function and it has symmetry to the y-axis. For this one, let's check. We want f of negative x. Well, let's think this out. If I expanded this and take x minus 1, the quantity squared, I'll get x squared minus 2x plus 1. Sometimes it's good to know that. Here, if I take negative x minus 1, the quantity squared. Negative x times negative x will give me x squared. Multiply these and double it, I'll get positive 2x. And negative 1 times negative 1 will be plus 1. This is the same, this is the same, but these two signs are different. So, is it even, odd, or neither? Well, it's not equal to f of x. It's not equal to negative. Not all the signs are changed. So this is neither. And it does not have symmetry to the x-axis or the origin. I will tell you, this happens to have symmetry, and we'll discuss it more tomorrow. Later, this actually has symmetry to x equals 1, but we'll discuss later why that's true. But it's here with its negative 1 symmetry. Well, let's find x, f of negative x. So 3 times negative x plus 7. That'll give me negative 3x plus 7. Not identical, but all the signs didn't change either. So this is neither. And as you might recognize, this is a linear equation. It's a line, and there is no symmetry. There is no symmetry there. Let's find this. F of negative x. That's the square root of 9 minus negative x squared. Oh, negative x squared is just x squared. We're back to the same. This is an even function, and it has symmetry to the y-axis. You might recognize this as the top semicircle, and of course that semicircle is symmetric to the y-axis. We want to solve this inequality just looking at the graph. We want to find out when is this inequality greater than or equal to 0? Well, that's based on the x-axis. Here's the x-axis. When is it greater than or equal to 0? Well, it would be here and here. Those arrows mean it goes on forever. So between here and here, the x values. We look at the x values. It's greater than or equal to 0 from negative infinity to, here we know that this is at negative 3. It's or equals, so it's a bracket. And that's also combined with this 3, it's or equal for the bracket, to infinity. So that's where it's greater than or equal to 0, because we have 4x squared minus 4 graph here.